Happy semester 2, everybody. This is Mrs. Marquette, and today we're going to start the Solving Quadratics chapter. And the big thing to know about this chapter is that everything's going to be about quadratics, and quadratics are equations or expressions that start with a highest power of 2. So I might have a coefficient, but then the highest power of my variable is always going to be a 2. So here I've got ax squared plus bx plus c. And today what we're going to do is we're actually just going to talk about graphing these quadratics, because in later lessons we want to know what these quadratics kind of look like so we can see what's really happening when we solve for variables. So we're going to look at the vertex form of a quadratic equation, or a parabola. And you'll notice that my equation, y equals ax minus h squared plus k, looks a little bit different than ax squared plus bx plus c, but we can see that my highest power on x is going to be 2 if I went ahead and multiplied out this whole function. So we're still dealing with a quadratic, and we're going to see that these characteristics are all going to come from this formula. We like this vertex form because it's the easiest form to graph in. Specifically, it's really easy to find the vertex. So our vertex, based on y equals a x minus h squared plus k, is going to be h, comma, k. This h is going to be right here. And the thing to note is because of that subtraction sign in front of the h, I'm always going to have the opposite sign of what is inside the parentheses. And our k, because there's a plus with the k, this is going to be the same sign. So things to keep track of. Number 2 characteristic is whether the parabola opens up or down. Pretty much if it's looking like this, it's going to be up like a cup, or down like a frown. So that's kind of the 2 shapes that our parabola might have. So if a is greater than 0, meaning that a is positive, then our function is going to open up. If a is less than 0, meaning that a is negative, then our function is going to open down. So positive up, negative down. After that, we're going to not worry about the positive or the negative. So I've got a positive or a negative out front. Now we're just going to look at the number. So that's what this absolute value means. It says don't worry if it's a positive or a negative. Just look at the number itself. And if the number out front is 1, meaning it starts just with an x squared, my width is going to be normal. So we've talked about Plato, how if I have a parabola, or we talked in the past about absolute value functions, if I multiply every single number by 1, or if I want to keep everything the same here, multiplying by 1 doesn't change anything. So I'm not going to stretch, I'm not going to compress, I'm just going to have a normal width of my Plato, or in this case, my parabola. But if a is less than 1, these are numbers like 1/2, 2/3, 0.75, anything that is less than 1, I'm actually trying to make that parabola, or you can think Plato, like half of the size, or 2/3 of the size, or 0.75 of the size. So that's actually going to be squishing that whole parabola down, and if I squish like Plato down, I can think about that getting wider. So if a is less than 1, my parabola is going to be wide. And then finally, if a absolute value is greater than 1, those are numbers like 2, 3, 10, etc. I'm trying to make my parabola be twice as tall, or 3 times as tall, or 10 times as tall. If I stretched Plato to be twice as tall, it's going to get really skinny. So we're going to call this narrow. Okay. And our parabola, if you recall, looks like this, or it could be facing down, but we actually have a symmetric graph here, meaning that if I folded this graph right down through its vertex, I would actually be able to fold one side right on top of the other. So our axis of symmetry has to go through the vertex. It's a vertical line, so it has to be an x line. So I'm just going to match that x value with my vertex x value. So this is x is equal to h. This I will be giving you for a test, so as long as you're able to apply this box, you should be okay. So let's try a few and see how that kind of works. It says, graph the four characteristics and sketch the graph. And you'll notice this parabola, it's already sitting there. That's like what a normal parabola looks like, a parent graph. So that is the parabola y equals x squared. Okay, so you're saying, how is that parabola moved left, right, up, down, etc.? So first of all, I'm looking at the vertex. Vertex is h comma k. My h is 1. I've got to change the sign. It was negative. Now it's positive. And my k is 2. Then I look out in front. My number out front of the parentheses is 1. That's positive, so it opens up. My width, again, it's 1 out in front, that a value. So my width is normal. And for axis of symmetry, I'm going to match with my x value. So it's going to be a vertical line through x equals 1. The vertex is going to be a really good anchor point for us when we're graphing. So I'm going to have my vertex at 1, 2. So I go x1, y is 2. And then I'm just going to graph a parabola that opens up and is relatively normal. I'm not too worried about you hitting specific grid points. I just want you to kind of have a parabola that has about the same width as the original parabola on the page. And then I also do want you to graph the axis of symmetry. So that's going to be a vertical line that's right through the vertex, so right down the middle of your parabola. We draw it as a dotted line because it's not really on the graph. It's just kind of, we can think about folding over on that line. And that's really what we're doing for all of these problems. So you're going to find your vertex, find which way the parabola opens, how wide it is, normal, narrow, or wide, and then draw the axis of symmetry. Number 6, if I look at the vertex, again, I do h comma k for my vertex. My x value always is with x, so x is going to be 1, the h is 1, and k is 2. Notice in the parentheses I had a minus, so I have a plus, and then my plus 2 stays the same because there is a plus k in the original equation. This opens up because the 3 is positive. But then if I think about stretching my parabola to be 3 times as tall, that's going to stretch it to be taller, which means that it's going to be more narrow. I'm stretching it up. And finally, my axis of symmetry will be x is equal to 1. So I'm still going to 1, 2, opening up. But this time I want to draw something that's more narrow than the one that I drew last time. And still draw my axis of symmetry right through the middle. Looking at number 7, you can look first at the vertex, see if you can get that. Hopefully you saw that you had to switch the sign on your 3 to be a positive 3, and then negative 2, the sign stays the same. This still opens up because the 1/4 out front is positive, but I have a wide graph here because I'm taking my parabola and I want to make it a 1/4 as tall. So I'm going to squish it down, which means it's going to get wide. And axis of symmetry, match your x value, and I can go ahead and graph. So to the right, 1, 2, 3, down 2, opens up and it's wide. Again, I don't need it to be too crazy perfect on how wide it is. I just want to sketch. And then our axis of symmetry does have to go right through the vertex. Number 8, my vertex is negative 3, 2. The difference this time is I had a positive in the parentheses. Because of the negative in the original equation, I switch it to be negative. This parabola opens down because of my negative out front of a. This parabola is wide because 1/4 is squishing down to be a 1/4 as tall. and my axis of symmetry is x equals -3. So you can get all of that from that vertex form of the equation, which is why it's so nice. So I go -1, 2, 3, up 2. It's opening down, and it looks generally pretty wide. Draw your axis of symmetry, and that is all you need. So that was nice. That was vertex form of your equation for a parabola. Sometimes you're not given vertex form. Sometimes you're given f of x is ax squared plus bx plus c. So we still want to have a way to find the graphs of these parabolas. We have a nice formula just for the vertex of a parabola. The x value of the vertex of a parabola is always the opposite of b over 2a. So that's what I have in this x coordinate. The y value, once I found x, I can really just plug in x and see what happens. Okay, so that's really what's happening here with f of -b over 2a. First find your x, and then just plug it in to find y. So I'll show you what that's going to look like. Notice that in standard form, I have a, b, and c. A is always with x squared, b is always with x, and c is always your constant. So for f of x equals 2x squared plus 8x plus 7, my x will be the opposite of b. So if I label these a, b, c, the opposite of positive 8 is -8 over 2 times a will be -8 over 4, which is -2. So I know that the x value of my vertex is -2. To find y, f of x, this is just another name for y. So y is going to equal 2 times whatever x is squared plus 8 times whatever x is plus 7. I know that x is -2. So I get y is 2 times -2 squared. So 2 times 4 plus 8 times -2 is -16 plus 7. You can plug that all into your calculator, or you can keep working it out. You get 8 minus 16 plus 7, which ends up being -1. So our final answer here is -2, -1, just for your vertex. Looking at number 10, if I have x is the opposite of b over 2a, here x is the opposite of 6, so -6, over 2 times a. A is -1. If I work this out, -6 over -2 will be a +3. And for y, I'll just plug in x, because again, y is just another name for h of x. So y is going to be equal to whatever I get when I plug in x. So y, there is an ice cream truck outside. That sounds delicious. Y is -1 times 3 squared plus 6 times 3 minus 8. So again, you'll notice that I had x's. I know what x is, so I just plug in 3 everywhere I see that x. So I get y is equal to -1 times 9, which is -9, plus 18 minus 8. If I work that out, I get +1. So here my vertex is 3 for x and 1 for y, and I'm good to go. When I actually look for the 4 characteristics and sketch the graph, I'm really looking at the same process as I was for vertex form. The only thing that's going to be different is finding this vertex. So looking at number 11, if I want just the vertex, because that's my first characteristic, I have x is the opposite of b, so in this case the opposite of b is 4 over 2 times a. So 4 over -4 is -1, and then I can plug in for y. So y is -2 times -1 squared minus 4 times -1 plus 7. So you can, again, plug that all in or kind of work it through. I get -2 plus 4 plus 7 is y, or y is equal to 9. So my vertex will be -1, 9. So if I actually go to graph this, I get -1 and then up 9. It's a little funny because these aren't the best graphs for such a large number. But then I can still look at, does this graph open up or down? Still using A from out front. So since there's a negative, this is going to open down. Then I look at the number 2. 2 is larger than 1, so it's going to stretch and be narrow. And finally, I want my axis of symmetry. Axis of symmetry is x equals -1. So when I graph, I have a graph that opens down, that's narrow, and looks about like that. Okay, final problem. Again, it's not in vertex form, so I actually have to go and find my vertex. Vertex is the opposite of b over 2a. The opposite of b here is 4 over 2 times a, which is 1. So my x is 2, 4 divided by 2. Plug that in. Y is 2 squared minus 4 times 2 plus 8. So I get 4 minus 8 plus 8. Y is equal to 4. Okay, so vertex, x is 2, y is 4. If you want, you can already graph that over 2 up 4. And then from there, we can use our other information to find the other characteristics. So I look at my a value. A is 1, positive. So since it's positive, I'm going to be drawing up. Since the number is 1, it's going to be normal in width. And finally, our axis of symmetry is x equal to 2. So draw your little parabola, faces up, it's pretty normal in width, and then my axis of symmetry is right through the center. So that is graphing parabolas. You need to know those 4 characteristics. Really what you need to know is how to use this formula in order to find your characteristics and graph, because again, you'll get these characteristics on a test. You would also need to be able to use this formula, x equals opposite of b over 2a, and be able to plug in x for y. So those are the big things to practice when you do your practice problems. Bye, guys.